throughout the last few projects, we've built a 7-segment display driver in Verilog, and then we're able to connect to the ARM processor and be able to use that hardware, that custom Verilog hardware, through embedded C language. That really doesn't do full justice to the capabilities of the Zynq processor that's on the ZedBoard. This next series of videos is going to set up a build system that will allow us to build a custom Linux distribution for the ARM processor on the ZedBoard and be able to deploy that system to the ARM and boot up the ARM in Linux, and then we'll write a custom kernel device driver for that 7-segment display, and we'll be able to use C language programs to be able to access that display. So it seems like it's a fairly big hurdle, but the good folks here at Yocto have created a really handy system for building Linux from source code, custom embedded systems. There's a whole series of tools that this thing depends on, and they have a nice quick start that we can follow. This is the Yocto project. I'm just going to walk through the quick start here, and unfortunately I don't have time to go through a lengthy explanation of every one of these steps. We'd be here forever and ever and ever. But the idea is that I need to create a virtual machine that is going to be able to handle the Yocto software itself. Once that virtual machine is installed, we're going to run the setup. I'm going to be using Ubuntu. Once we have the setup, we can roll through the git clone to clone the Yocto project, and then we'll run through the Bitbake system and we'll build a custom Linux distribution. So let me go ahead and bring up VMware, and I have an Ubuntu CD-ROM already downloaded. I'm going to make a new virtual machine, and I want to browse to the image that I've or the ISO that I've already created, and I have that stored here in my virtual machines directory. And I want to put this virtual machine so I'm making the user ID Yocto, the password Yocto. I want to make sure that this machine is somewhere on my C drive. I have a solid state hard drive. Yocto is a fairly disk intensive process as well as CPU intensive. So we're going to go ahead and call this Yocto Linux. That will be the name of the virtual machine. It's going to be on my high-speed internal drive. It also needs quite a bit of disk space. So I'm going to make this thing 125 gigabytes. That does not mean that the VMware is going to create 125 gig of disk. It will allocate up to 125 gig of disk, but it'll do that allocation as it needs it. Before I go ahead and continue here, I want to go ahead and change the hardware configurations. I'm going to make this thing have a bunch of memory. I have 32 gigs of memory available, and so I'm going to make 12 gigs of that system memory available to this machine. I have a 12-core processor, and so I'm going to go ahead and use 8 of those cores for Yocto, so that will leave 4 cores for Windows. The other possibility is I could do all 12, and maybe that's not so bad. Yocto really does use a lot of cores. The more we can throw at it, the better. So at this point, VMware is going to go ahead and do kind of a managed build. They call it an easy install. And what's going to happen is, because VMware has detected I'm installing a known Ubuntu, it's just going to go through the whole setup process for me. It couldn't be any easier. Okay, so Yocto finished. I can try to log on here with my password of Yocto. And if all went well, I should have a working Linux system. So, had to kill the X Windows server, and now we're back into business. Alright, so we'll come back up with the terminal window here. And the next thing I'm going to do is I'm just going to follow the script that Yocto has provided. And they say I need to sudo apt-get install. That's the Ubuntu way of installing software. And this is just going to go ahead and download and install a number of support packages that we're going to need for being able to build the Yocto system. So far, this has taken about 8 minutes to get to this point. Okay, so I've met those prerequisites. The next thing it says I need to do is I need to clone the latest Yocto repository. And so this website claims that it's Pokey. That's the name of the current. And so we'll go ahead and just execute what they tell me to execute here. Okay, so at this point, following the get download, we have finally been able to download the Yoctos. The real time here is about 24 minutes. We're almost half an hour in. The idea is that once we have the software, we're ready to begin to build. So let's take a look and just kind of see what they've given. So after this great big download, I have this Pokey directory that has all of the information in it. I've learned from previous experience that there are times we're going to want to go back to right now. And I don't really want to lose that whole half hour that we've just done. And so one of the beautiful things about VMware is I'm going to take a snapshot, and I'm going to name this snapshot Yocto get finished. Yocto get just finished. Other changes. So once I've taken this snapshot, if I ever have to go back and make a change, I'm not going to lose this state. This is kind of like the golden state. If I make a mistake, I can undo it without any problems. So it turns out some of the documentation indicates that in order to use Yoctos, you need to have the Xilinx Tools installed. Unfortunately, I can't find any exact evidence that that's true, but we're going to go ahead and install the Xilinx for Linux. If you don't have access to it, don't worry about it. It seems to build without it, but better safe to be sorry with these things. So it turns out right here there's a number of 32-bit libraries that are needed to be able to use Xilinx successfully. I'm going to post a link to all of this stuff onto my website. At the end of this video there will be a link to the Xilinx page that I maintain. I'll have all of this stuff posted there. Don't worry about it for now. Okay, so at this point I have the Yocto get repository downloaded. I have the Xilinx tools installed. They're in my path. The next thing I'm going to need to do is to get into the Yocto directory, which is here in Pokey, and I need to clone the Xilinx tools for Yocto Linux. And to do that, I'm just going to copy and paste a command. I'm going to put a worksheet up on my website. It'll be linked at the end of this video that has all of the commands that I executed to do everything that you see today. But anyway, we're going to do a git clone. I don't want to do the Dora branch. I'd like to try to do Pokey, but I know that there is no Pokey branch. The most recent branch that apparently they have on their web page is, let's see, Morty. Morty is the most recent branch. Alright, so we'll grab Morty, and then the other one that we're going to need is the Open Embedded tool, and we're going to do basically the same thing here. Now that we're using Morty, everything else has to use Morty as well. Oh, I can't type. Git clone. So the -B flag is just saying what branch that we want. This will just take a few seconds. Or so. Maybe a minute. Maybe 2. Feels like 3. Okay. The last thing I'm going to do in this directory is I'm going to do a get checkout. Oops. So now the top level Yocto is connected to their Morty branch as well. So all 3 tools are living on the Morty branch. The way Yocto works is that there is a command that we use to kind of kick off the build system, and that's going to be this open or OE init build. So I'm going to type in the source command. The source command is a Unixism that allows me to run a shell script and have it change my environment variables. So the OE init build can actually create changes to its environment variable, and then the source command will read them back and put them into my current shell's environment variables. It's a really powerful way to be able to extend your current shell without having to have another shell, a child shell. At any rate, it's going to set a whole bunch of configuration options for me, and what I want to do now is kind of adjust them for our work here with the ZedBoard. To do that, there's a couple configuration files I want to edit, and the first one is in this build directory. It's the local.conf file, and really what's in here that I'm interested in right now, whoops, went right past it, is I don't want to use the QEMU machine. Rather, I want to use, man, I can't even type, the ZedBoard zinc 7 command. So, or machine. So this is just telling the tools what machine and what environment do I want to build the system for. The next thing we need to do is to edit the layers file, the BB layers file. The command Bitbake is going to read this file and determine what packages, like what overarching packages need to be included in a build. And in this case, it's going to be our meta Xilinx. And then the other one that we're going to have in here is the meta open embedded meta OE. So those were the 2 meta packages that we had to bring in. These are just these are kind of like overarching packages that can include other packages. And at this point, we can go ahead and save the file. And the next thing we're going to want to do is to run Bitbake, just like what it said here. So I could choose, for example, to do any of these 4. Really what I want to do is go ahead and just do the core image minimal. This is going to read in all the configuration. It's going to figure out what packages need to be downloaded and compiled. It's going to build a cross compiler to run on my Intel machine but create code for the ARM CPU that the ZedBoard has. It's going to create a bootloader. It's called Uboot. It's going to compile a kernel. It's going to compile all of the packages. It's going to take a long time. Several hours on a reasonable machine. Even with my 12 cores and the memory that I was able to throw at this process on a solid-state hard drive, it's still going to take a long time. A big factor is also the speed of your network connection. My campus has a high-speed gigabit connection. We'll see here in a second where it actually tries to download 12 packages, or however many cores you have. It tries to download those packages at the same time. There it goes. And so, I mean, even though it's running through these things very quickly, it has a lot of things to do. So I'm going to stop this for now, and I'll come back when this is finished. Alright, so it looks like the process finished. The time right now is 1:40 Pacific time, and if I look at the conf bb layers file, which is one of the last things we did, it looks like it was 12:19. So it took about an hour and 10 minutes to build on this machine. That's actually not too bad considering everything that it did. All of the files that it built are located in the temp directory. There's a deployment folder, and then there's an images file, and there's a ZedBoard Zinc for this machine. And what I have out here then are a whole series of different files. The Uboot file is the file that is loaded first. When the system boots up off of the SD card, there's a first stage bootloader that will look for the Uboot files. We need to make sure that is copied onto the SD card first. Then we need to be able to have a file system, and the file system is right here. This is the file system that the operating system will load, and will have all of the commands that are available to us. Finally, we want to have a kernel, and the kernel that we're going to use is this uimage kernel, which is right here. This is the kernel that will be loaded by Uboot. And so what happens is this first stage bootloader, which is actually in a firmware on the ZedBoard, will load the Uboot file first. The Uboot file will set up the machine, load an SD card driver, and give me the opportunity to find the kernel. The kernel will then boot up and run and take over from Uboot. And the kernel will then look for a root file system, and that root file system will be this Uboot file right here. Once that's done, the operating system Linux will be up and running, and whatever custom commands we've chosen to include in our boot system will be present. So at this point, I tried to make a root file system using an SD card and used Minicom under Linux. Both of those failed. The SD card I was using, looking at it now, I can tell is dead. There's actually a dead pin on the back of it. Went and got another USB card and switched over to using RealTerm under Windows, and all was much better. What I want to do is I have a new one that has a one partition on it. I want to delete that partition. Oh, I did that wrong. Alright, new primary partition, partition number 1. We'll make it 100 megabytes. And then we'll do a new partition, partition number 2. And I need to do a type for partition 1, and I want to make it an MS-DOS. MS-DOS FAT16. looks like type 6. And we can write that out. So I'll eject the SDD, reinsert the SD card, and voila, I now have two partitions. Now I can do my make fs or make DOS-fs dash name Yocto all stream dev SDD1. I can mount that. Looks like it already is. Nope, it's not. There, now it's mounted. And we can do our CP here. Oops, put it in the right directory this time. Mount. Okay, so that drive has been ejected. Okay, so I know this next bit is going to be another great example of fine photography. I can go ahead and unplug. Turn this guy off. Alright, so the ZedBoard has a series of jumpers, configuration jumpers right there. Yours may have defaulted to all in a line on the off side. That's going to be appropriate for booting off of the JTAG port. So when the board comes up, it's going to wait for a program to come in over the USB wire. Because we want to boot off of the SD card, manual says I need to move JP9 and JP10 up to the 3.3 volt side. So those two jumpers, I've already moved them. Those two jumpers go up to that. And then the SD card here goes on the bottom. So there's the bottom of the ZedBoard, and we're going to slide this SD card in. Looks kind of upside down if you're looking at it top side up, but put that in firmly. With the board still powered off, there's a good chance that we won't see the USB UART. I'll insert it in and so it says it can't find system DTB. Alright, so been a while since I've had to put up with this. Auto mounter found it that time. Alright, so then do I see a system DTB? I do not see a system DTB. U-boot. Media Yocto. Okay. Okay, so eject it. Hit the reset button. Hey! Would you look at that? Oh no. Well, our first kernel panic. I'm sure it won't be our only one. It looks like it tried to mount a root file system and did not find one. So one thing I can do is I can take the SD card out, put it back into my PC, and we can now go to use So I'm going to make a root file system now. So I'll do the makefs ext3 command, this will initialize that second partition, almost 2 gigs partition, and it'll be completely brand new and empty. And if I mount that partition, I see that there's just a root directory and it's all empty, for lack of a better term. The Xilinx, or the Yocto build system made a file system for me. I see it here. This core image tar file actually has everything I need in it. So if I do a tar xvfz and I do that to Yocto, oh my, what a long, terrible command. Thank goodness for autocomplete. Okay, so I'll CD out of it, I'll unmount it, I'll eject it. We'll go over here to the board again, hit the reset button. Hey, and this time it mounted the second partition, and it's actually trying to boot over the Ethernet. And if I were to reach around or dig around here in my office and look for an Ethernet device, I'm sure I could find that. Looks like I can log in now as root. If I look around here, I can cat proc CPU info. And it looks like we have 2 ARM7s at 666 megahertz. Man, the serial emulation here is really quite terrible. Well, I I just switched over to real-term. It's rare that Windows does a better job with this kind of stuff than Linux does. But let's go ahead and reboot and see how many characters we drop. So again, I'm hitting the reset button. Looks like auto boot is booting. There goes the kernel. Oh, much better. Okay, so let's do a df-h. Look, I've got 1.6 gigs available. So at this point, what I've been able to do is to bring up a board from nothing. This is a custom operating system built just for us. No other one just like it. So that's long enough for this video. In my next video, we're going to talk about writing a custom device driver and plugging it into the Yocto distribution. Thanks for watching.